Here are your notes on molarity by dilution. So this will get you prepared to do your dilution practice problems as well as do the molarity by dilution lab. So acids are usually acquired from chemical supply houses in concentrated liquid form, and these acids are diluted to desired concentrations by adding water. We always add acid to water. We never add water to acid. So since moles of an acid before dilution equals moles of an acid after dilution, and the moles of an acid are equal to the m times v, then we know that m1v1 equals m2v2. So moles of your concentrate times by volume of your concentrate equals moles of your dilution times by volume of the dilution. So it's a very simple, straightforward m1v1 equals m2v2 equation. So the 1's are what you start with, and it's your initial, and the 2's are what you want to make or prepare. It's your final. So again, C for concentrate and D for dilution. So molarity by dilution practice, how much concentrated 18 molar sulfuric acid is needed to prepare 250 mils of a 6 molar solution? Well, if I set up my equation m1v1 equals m2v2, okay, here's my m1. I'm trying to figure out how much I need, so that's why that's my v1, equals v2 and m2. It's a simple algebraic solving for that v1. So we would end up getting 83.3 mils of 18 molar sulfuric acid. So if we wanted to figure out actually how much water I would need, I could then just subtract 83.3 from 250. So in theory, I know I would have, of that 250 mils total, 83.3 mils would be the acid and 167 mils would be the water. I'm never going to actually make you specifically measure out the water. You would simply just bring the water to the volume needed, just so you know. So molarity and dilution titration practice. So if I want to make up 500 mils of a 3 molar solution of HCl from concentrated 12 molar HCl, how much of the 12 molar solution do I need? So I'm going to use my dilution equation. I'm going to use m1v1 equals m2v2. So I know that I've got 12 molar times v1 equals 3 molar times 500. I'm going to solve, and I'm going to figure out that I need 125 mils of a 12 molar HCl solution. So now what we're going to do, this is going to prep us for our lab, because you're basically going to do a calculation for a dilution, and then you are going to actually titrate to see how well you did. And so let's say that we did that titration. Let's say we made up our dilution acid. Let's say we did that titration and we take 10 mils of the solution that I made. Hopefully it's 3 molar, but we're going to check that out to see if it is. And I add an indicator and I titrate it with 1 molar NaOH, and I find that it takes 28 mils of NaOH to actually reach my endpoint or my equivalence point. So in this case, because I know more information about the base and I'm trying to find my acid molarity, I'm going to use the T-charts that I'm familiar with. So I'm going to start with my liters of my base, and I know that liters of base goes on the bottom, and I'm going to use my molarity of my base because it's given to me in my problem. It's 1 molar. And I'm going to go 1 to 1. And then I'm going to use mole city. And I kind of cheated and didn't write out the chemical formula here, but because these are both monoprotic and that is the equivalence of 1 and that is the equivalence of 1, I know that this is going to be a 1-to-1 ratio, so I'm able to fill that in. And then I'm going to leave moles on the top of HCl, and I'm going to fill in my liters of HCl. Now, notice, 125 milliliters does not go on the bottom there. I only titrated 10 mils. I cannot tell you enough that this is the biggest mistake that people make in the dilution lab math, is that they put this number down here. You did not titrate 125 mils of your acid. That's how much you got out to make your volume. You titrate 10 mils of your acid. It is really important that you remember that. Please, please, please watch yourself on this one, okay? So notice, you do not titrate 125 mils. You only titrated 10 mils, and this is exactly what you will do in your lab. You will make 25 mils of a dilution, but you will only titrate 10 mils of that acid to check to see how well you did on your concentration. So you should only have 0.01 liters down here of acid in your lab as well, please. So be very careful with this. So once I do my calculation, go ahead and hit pause so that you can do your calculation. Okay, so hopefully you calculated that you actually created a 2.8 molar HCl solution. So my target was 3, so I know I'm going to need to do my percent error. So my lab was 2.8, my actual was 3. So I'm going to fill in lab minus actual divided by actual. Remember, this is absolute value multiplied by 100. So I'm able to get 2.8 minus 3 over 3 times 100. And that gives me a 6.7% error. And so in the monoprotic and diprotic titration lab, I wanted you guys to have a 5% error or less, but in the dilution lab, totally acceptable to have an under 10% error. There's more room for error in the dilution lab because you're actually creating the solution, and so totally okay if it's under 10% error. Because most of the time, your error comes from the dilution and not from the titration in this lab because you guys have gotten good at it. Okay, so you can work on your dilution practice problems and then start working on setting up for the dilution lab.